Hey, pre-cal honors. Okay, so we are starting section 5.4. This is notes day 1 of 5.4. So notice we are going to solve trigonometric equations today, and we have some trig identities right here, double angle identities. So we have sine 2x equals 2 sine x cos x. Notice we have 3 identities for cos 2x, which I think you could derive them pretty easily if you wanted to. So notice if you look at cos 2x equals cos squared minus sine squared, we know that the cosine squared of x plus the sine squared of x equals 1. So you could replace cos squared with 1 minus sine squared. And notice that's 2 sine squared. Similarly, you could replace sine squared with 1 minus cos squared of x and, get that out of this. Really, there are 3 listed. But again, I have the other ones pretty easily. So why don't we go ahead and start with problem number 1 as a solve. And I'm going to show you 2 ways to solve this one. The first way, we're going to use a trig identity. We know that sine 2x is 2 sine x cos x. Okay, because that's a trig identity for a double angle. So we know that the sine is 0 or the cos is 0. So we're looking for answers when the sine or the cosine is 0. So part A, it's all about the interval here. So the part A, we're saying, let's say x is between 0 and 2 pi. So you would say 0, pi over 2, pi, 3 pi over 2. So those are the answers for x for part A, between 0 and 2 pi. And then for part B, we want all real radians. So you would say x equals pi over 2. So that's one way to solve this problem. Here's another way. For this next method, this is a little different. What I want you to do is think about, like, what if we just left? What if we just left sine 2x? So what I want you to do when we graph this time, I want you to think about 2x. So we're not sketching a graph for 1x. We're sketching a graph for 2x. So it's almost like we're thinking like, okay, that's like sine of some angle. And when we graph it, the sine of some angle, 2x, equals 0, right? Well, let's think about that. The sine of an angle is 0 at 0 and pi, and again at 2 pi. So again, we're thinking of this as 2x right now. And x is between 0 and we are going to be looking for values of 2x between 0 and 4 pi. So for part A, 2x is between 0 and 4 pi. So the only thing is they didn't want to know what the value of, what the answers would be for 2x. They want you to solve for by 2. And if you look above, that is the same answer we got for method 1. And then for B, again, if I'm looking at 2x, you would say 2x would be pi k. But again, that's not what we wanted. We wanted to know the answer for x, so you divide everything. So that's another way to do it. Let's do one more problem, and then again, we'll have the notes video in 2 parts here. Let's go ahead and try number. So this one, notice it says cos squared of 2x equals 1/2. So if I take the square root of both sides of the equation, your choice, you could use a trig identity, or we could solve it the same way we did last time. 2x, right, is what we're going to graph. So again, we have quadrants. And for part A, they're saying this time, let x be between 0 and pi. So if x is between 0 and pi, 2x is between 0 and 2 pi. So here we go. So that means that these are 4 is pi over 4, pi over 4, 4 pi over 4. Oh, sorry, not 4 pi. That was 5 pi over 4. Sorry, 5 pi over 4 and 7 pi over 4. Now, x then, you would have to divide everything. And that's part A. For part B, we could say 2x is plus or minus pi over 4, plus 2 pi k. I'm sorry, actually you just have to say plus pi k, right? If you look at the picture, plus or minus pi over 4 plus pi k would give you all of those answers. But again, we wanted to know x, so x by 2. Go ahead and pause the video and maybe try and you could maybe try and solve that problem if you wanted to using double angle identities. But I think this method might be quicker. Okay, so those were the first two problems, and I will have a second part of the video for the rest of the notes. Or actually, you know what? Maybe let's just do one more. We can do one more. So here's number 3. So for number 3, you could use a trig identity. Now it's up to you which one you want to pick. I would probably choose cos 2x is 2 cos squared of x minus 1, because then you would have all cosines in the problem. Right? So if I replace cosine 2x with 2 cos squared x minus 1, now I could get 0 on one side of the equation and factor. So again, it's up to you. You could factor by calling cos x u if you want, or you could just go ahead and factor, whatever's easier for you. So let's see if that worked out. That looks good. So you end up with cosine 2 cosine x plus 1 equals 0, or cosine x minus 1 equals 0. So I have cosine x equals negative 1/2, or cosine x equals 1. So now that we can solve that one, cosine of x is 1, cosine of x is negative 1/2. So again, for part A, x is between 0 and 2 pi. And again, notice we are graphing x this time. We're not graphing 2x. So for part A, then, you should have x equals 0, 2 pi over 3, and 4 pi over 3. For part B, I wanted to know all real radians. So we're finding all solutions in radians. So you would say x equals 2 pi k plus or minus 2 pi, or 2 plus or minus 2 pi over 3 plus 2 pi k. K is an integer. Great job, everybody.